Hi, it's Trevor from GHD-repair.co.uk. This video is purely for our customers. I just need to explain a couple of things. It's not for my usual engineer viewers on the channel, so if you are one of my colleagues, then there's absolutely no point in watching this video. If you're a customer or a potential customer, then do watch this. So the model we're going to be talking about today is the GHD Gold and also the wide plate version, which is the GHD Max. Model numbers S7N261 for the normal width and S7N421 for the wide plates. Now there's a couple of issues that we're aware of on this model, and one of them is they will appear to be completely dead, and it's because a small chip on the circuit board has failed. Now most, in fact all companies apart from mine and an engineer colleague called Kev, we both do the same things, collaborate, but only our two companies can repair the circuit board and change. I don't know whether you're going to be able to see this or not. Let me just stick it in the palm of my hand, see if that will focus. There's a tiny little chip fitted to the circuit board on these irons, and that chip contains software basically, and that software tells the irons what to do when the mains is applied, from monitoring the press of the buttons to the bleeping noises to the flashing LEDs. Everything is controlled by that small chip, and the code is written by GHD or whoever, whatever product this chip is in will have special code written for it to control the particular item that the company is selling. In this case it's GHD hair straighteners. So obviously the company, when they write the code, they do not want anyone getting their hands on it for obvious reasons, and there is a way to put the software onto this chip and then protect the chip so it cannot be copied, and that's what they do. So to save all of the circuit boards where this chip has failed, it would be a hell of a waste if that chip fails and we have to scrap the complete PCB. It's two PCBs with interconnecting wires. I should have grabbed one, but it doesn't matter. It would be an awful waste, and if this continues to happen, some companies may well run out of PCBs that they can exchange with, give you a replacement PCB that works. So we've spent must be 6 months developing our own software. Kev has done most of the work, and I've just been doing the testing, and I did some of the tones that we'll hear in a minute as well, and then I've recently just put the software through its final testing, and it's very, very similar in function to the original, and that's really what this video is about. So if we have had to fit a new chip, or we've exchanged the PCB for you that contains our firmware software, same thing, then I'm just going to show you the differences. So this is a normal bog standard GHD Gold, and this one is the one that we have had to program with our own software, firmware, call it whatever you would like. So first thing I'm going to do is have a listen to the bleep when this is plugged into the mains. So you get the long bleep and the flash, and when you power it up, 2 tones, and then this LED will start to pulse. We'll let it get to temperature and you can hear what it does then. And that's what happens when it's at temperature. Solid LED, the multiple tones play. Now if we're going to turn this off now, you press and hold the button, and a single tone, and it goes off. Now what we've done with ours, I'll apply the power, pretty much the same, and here's the difference. Rising tone to indicate that it's heating up. And a similar tone when we're at temperature, but we've added the reverse of the upward tones to signify it's turning off and cooling down when you press the button now. If you listen, a down sequence of tones, and that is pretty much it. Obviously we've built in all of the protection features into this, exactly the same as the original. So if an element's broken or a wire's disconnected, open circuit component, all of the original protection we have incorporated into our own code. We have also written this code because there's a known issue with this model and the wider one, where we find that the non-switch side element is cracked in two. There is a circuit board issue. We know what it is. We change a number of components on every GHD Gold or Max that comes in to eliminate any future problems, but we have to change obviously the cracked element. Now all of these elements are very slightly different when you check them for resistance. I'm not talking about the element itself, the control circuitry part of the element, shall we? Well, that's what we'll call it. Now that variation means if you just swapped an element from one iron into another one, or if you had some elements here in a pile and just grabbed a random one, you'll probably find that the temperature of the ceramic plate is too high or too low. It's very hard to match up the correct value of element. If you've got enough elements, you could try 2 or 3 and eventually come to the correct value, and that's absolutely fine. But it's long term is not going to be fine, because the likelihood is elements will run low and there'll be problems in the supply. So we then need to be able to use whatever element we have to hand from scrapped irons, the same models. So what we've done, in the software we have created a routine that you can plug in any element from this model, and at power up it will read those values and it will set the correct temperature, something that they would normally do at the factory, but of course we can't do that because their chip is locked. So whilst our chip is has newly been fitted, that one routine to start with will set the elements correctly. Obviously our chips are also write protected. We do that after programming, but if the chip should ever become corrupted, if you've had a big mains outage or a mains spike, surge, something like that, if that chip ever loses its code or it becomes corrupted, we can unlock the chip, reprogram it, and it will be good to go. No other company can swap this chip because they don't have the code, and we won't be supplying the code to anyone else. It's taken a long time to develop it, and that is part of the repair we will be offering. So yeah, there we go, just a quick look at the difference between the original code and our own. So you have that rising tone signifying the heat up, and when you turn them off you have that downwards tone indicating cooling down. All the other features, shiver mode, so if it's 8 degrees or less you will get a red flash and a bleep. All the other error codes are as per the original, and there is a 30-minute timer if the irons are just left on the side inactive. After 30 minutes they will turn themselves off. The latest version of the latest model of GHDs has a 10-minute standby timer, and we did consider lowering the golden max to 10 minutes. It's been done for energy reasons, not that they use very much in 20 minutes, but if you're not using them for 10 minutes, turn them off anyway. So yes, the new model goes to standby after 10 minutes, but we thought people have got used to 30 minutes. If they use that feature, they might be confused or annoyed that it's now 10 minutes. So we decided to leave it at the original 30 minutes. So yeah, there we go. So as I say, this is purely for our customers, and you will have read all sorts of weird things on other websites regarding this model. Some things about serial numbers, even though they can't repair certain serial numbers. For us it's irrelevant. We can repair every single pair of these, whether they've got a circuit board problem, chip failure or cracked elements, doesn't matter. Just send them in to us, and we'll take care of them, and we will modify the circuit board on every occasion so they are far more reliable in the future. Okay, so thank you for listening, and I'll leave a link to our main website where you can purchase the repair service if yours have failed.